Okay, physics students, we are going to begin to learn how to draw ray diagrams and then calculate image distance, image height, and magnification for objects that are in front of concave mirrors. And so we're going to start with the problem here, and it's what's the image distance Q, the image height H prime, and the magnification of an object that is 3 centimeters in height and located 25 centimeters away from a concave mirror that has a focal length of 10 centimeters. So I've put down the steps on how we're going to do that because that's a lot to handle. And so our first step is that we're going to draw an axis and our mirror to scale. A lot of times the problems that you have are going to have really long distances that are bigger than sheets of paper, so you have to be able to scale that down to fit it onto your paper. Then you're going to mark the focal point and the center of curvature. We have 3 rays that we're going to draw from our object to the mirror and back. In reality, you only need to draw 2 of these, but I'm going to show you how to do 3 of them so you can have your choice of the 2 that you choose. And then when those rays converge, that's going to show you where your image will form. When those lines intersect, that's the top of your image, and you draw from there perpendicularly back to the major axis so that you can have your image. When you're done with that, you can measure the image distance, Q, the image height H, and then you can calculate values for all of those, Q, H prime, and M, and then compare those to the measured values. And I'll do that too. So let's get started on the problem here. And so what I want to do is first draw the axis and the mirror. So it says that the object that we have is 25 centimeters away from a concave mirror. Well, 25 centimeters is, bigger than a sheet of paper, and so, or almost as big as a sheet of paper. So I'm going to cut all these numbers in half. So I'm going to start out just drawing an axis here. And because this is a concave mirror, I know I'm not going to be forming an image on the back of it, and I also know that this is going to form a real image on the front side of the mirror. So I'm going to draw my mirror over here. Now I'm not going to draw a real mirror, I'm going to draw sort of a straight line. And that represents my mirror. Now again, for a concave mirror, this is the front side where real images are. This is the back side, also known as mirror land. Okay, so the next thing I need to put in is the focal point and the center of curvature. The focal point for this mirror is 10 centimeters. So again, I'm cutting all my distances in half, and I'm going to mark this right here as my focal point, F. And I know that the center of curvature is 2 times the focal point, so I'm going to mark that right here. This is C, the center of curvature. Now my object is 25 centimeters away from the mirror, and so again, cutting that in half, that would be 12.5 centimeters. So I come out to here, and it looks like I made my line just long enough, maybe not quite long enough, but it's right here. So this is where my object is. That's the letter P. That's my object distance from the object to the mirror. Now I don't have an object there yet, obviously, I just have a dot. So I'm going to draw an object, and it's supposed to be 3 centimeters in height, so I'll cut that in half to 1.5. And I'm not going to make a really complicated object here, I'm just going to draw an arrow because it's easy to replicate. So this is my object, and again it has a height of 3 centimeters. Alright, so now I can start drawing some rays, and the first ray goes parallel from the top of my object to the mirror and then back through the focal point. So I'm going to use a purple pen here to represent that. And I want to make this as parallel as I can. And that looks pretty good. So I'm going to, here's my parallel line, and what is it parallel to? It's parallel to the axis. Now that hits the mirror, and it's going to reflect back through the focal point. And I just extend that a ways. I don't know where it's going to intersect, but again, this ray of light hits the concave mirror and reflects through the focal point. The second ray that I draw goes from the top of my object through the focal point and then reflects back parallel. Right. So again, it's coming in through here, hits the mirror, and it comes back. Now I can see already that I have an intersection there, and that's likely where my image is going to be. But I'm just going to draw the third ray, and that's the one that connects the top of your object through the center of curvature. And that should go all the way to the mirror, but it looks like I didn't make my mirror long enough. But it doesn't really matter. I just have to draw a ray that connects the top of my object through the center of curvature, like so. Now that ray would come down, it would hit the mirror and bounce straight back. There is no second line for that one. But what you can see here is that all three of those lines intersect, and that's where my image is. Now because this image is on the front side of the mirror, that means it's a real image. You can project that onto a screen, but all real images are inverted, so this image is upside down. So what I need to do now is measure the image distance Q, and that image distance, if I measure here, looks like it's 8 centimeters. But again, I cut everything in half, so that's really going to be 16 centimeters. And my image height is 1 centimeter. So h prime equals 1 centimeter. So this is all based on my drawing. So the next thing I want to do is I want to calculate what those values would be just based on the numbers we have. Now again, remember the object distance was 25 centimeters and the focal point or the focal length was 10 centimeters. And we can use the mirror equation now to solve for what Q should be. The mirror equation is 1 over P plus 1 over Q equals 1 over F. Alright, well, I want to find 1 over Q, so I'm going to bring 1 over P over to the other side. And so what I end up with here now is 1 over Q equals 1 over F minus 1 over P. And that's going to be 1 over 10 minus 1 over 25. With a calculator, I could use the x minus 1 feature. I'm just going to get a common denominator here. So I'll use 50. I've got 5 fiftieths minus 2 fiftieths equals 3 fiftieths. Now, again, that equals 1 over Q. So I need to flip both of these over, and I get Q equals 50 thirds, or 16.7 centimeters. So that's what my value for Q is. Now what did I measure it as? I measured it as being 16, so my drawing was pretty good, if I do say so myself. Alright, now to find the h prime, the height, I'm going to use the magnification equation. I know that h prime over h equals negative q over p. And so to solve for h prime, I actually get h prime equals negative qh over p. So that's going to be negative 16.7 times the initial height, which was 3, divided by my object distance, 25. And I get negative 50.2 approximately divided by 25, and that equals approximately negative 2. Alright, so that is my h prime. And notice that negative sign there. What does that negative sign mean? It means that the object is upside down. And over here I got 1 centimeter. Well, there's a mistake I made here. I measured that. That is 1 centimeter, but again I cut all my numbers in half, so in reality that should be 2 centimeters. So 2 centimeters there, 2 centimeters here, and those numbers agree. And the last thing to do is then to find the magnification. Magnification equals negative q over p, and that is going to be negative q is negative 16.7, p is 25, and that's going to be approximately negative 0.67. So what that's saying is the negative sign is telling us that the mirror will invert the image and make it 2/3 the size of what it initially was. And that is what we found. This is 2 centimeters, this is 3. So that's finding an image for an object that is outside the focal point in front of a concave mirror. Alright, let's say, okay, now I'm just going to sketch the next example, but let's say that I have an object that is inside the focal point of a mirror. So I'm going to just sketch this out. I'm not going to do an actual problem on this, but I'm going to draw an axis here. And I'm going to draw a little mirror. I'll draw it over here. And we'll say that I have a focal point that is right here. And I've got an object inside the focal length, so it's between the focal point and the mirror. Okay, so I still draw the same 3 rays I did, but they're going to behave a little bit differently. So the first ray that I draw goes parallel to the axis from the top of the object. And again, it's going to reflect back through the focal point. Now the second ray that I draw is going to go through the focal point and the top of the object to the mirror. But then that one reflects back parallel. So this ray of light is coming like this, and then it bounces off the mirror parallel. Now you can see this ray and the purple ray are never going to converge. They're never going to make an image here. And just for fun, let's do the center of curvature. I'm going to have to extend my axis a little bit here. Alright, and I know that my center of curvature is 2 times what the focal point is. My focal point is 4.8, so that should be 9.6. So right about here. And so I need one ray that connects the center of curvature to the top of my object and the mirror. And again, rays that go through the center of curvature, are incident this direction, but they bounce back directly on themselves. And again, that ray is never going to converge. You're not going to get an image on the front side of the mirror here. So what do? You take the reflected rays and you extend them as if they were coming from the back side of the mirror. So here's the reflected ray from my purple line, and I'm going to just draw a dotted line to show that this isn't a real ray, but nevertheless, that's what our eye perceives it as, perceives it coming from. The red ray, this is my reflected ray up here, so I'm going to extend that one back. And my center of curvature ray, I'm going to extend as well. Well, like I said, this was just a sketch, so I didn't measure everything perfectly, and so it looks like my intersection is kind of this blob over here. So I'll say that's where it intersects. It's not too bad. All right. Now, again, I extend from that point down to the axis, and this is my image. Now, notice in contrast with the last one, this is upright and it's larger. So I've created a larger image here, but it's on the back side of the mirror. So this is my new Q, but any Q distance that is on the back side of the mirror means that Q is negative. So when I measure that distance, I'll get, some number of centimeters, like let's say, I don't know, 8. That would be a -8. Q would be -8 in this case. So there you have it. Drawing rays for concave mirrors.